Hi, my name is NURDANILA dan MAISARAH binti NOORAZIZAN. Today I want to talk about type of organic reactions. Let's explore organic reactions. To understand how material like fuel, plastic and medicines are produced, we need to understand organic reaction chemical process involving carbon compounds. Today, we look at the three main types is additions, substitutions and elimination, and how each one changes a molecule. Three types of organic reaction is for addition, essence, react with hydrogen to form essence. For substitution, methane react with chlorine to produce chloromethanes. And the last one, for elimination, essence loses water to form essence. Let's understand about definition and comprehensions. First, addition occurs when two molecules join to form one product. Then, substitution happens when one atom or group is replaced by another. And the last one, elimination takes place when atom or group are removed, forming a double or triple bond. How does it happens mechanism? A reactions mechanism show how a reactions happens step by step. For example, in this substitution reaction, the hydroxide ion attack the carbon and replace bromine to form metal. In conclusions, addition, substitution and elimination reaction are important to organic chemistry because they change molecule in various ways as demonstrated by their balance equations and mechanisms. These reactions are also necessary to create a variety of practical compounds that's used in everyday life. That's all. Thank you.
Hello everyone, my name is NAJIHA and I will present about alkene. Alkene is unsaturated hydrocarbon. Let's look at IUPAC naming rule for alkene. There are 5 simple steps to follow. First, identify the local carbon chain that contain the double bond. This chain will be your main structure. Look at the formula structure. The longest chain with the double bond has 4 carbon, so the parent is good. Second, change the suffix from "-ene" to "-ine" to show it's an alkene. Let's make the parents butene. Third, number the chain from the end that give the double bond the lowest possible number. Numbering from the left, the end nearest the double bond. The double bond is between carbon 1 and carbon 2, so the locale is 1. Fourth, indicate the position of the double bond with a number before the name. Put 1 in. Lastly, name the substituent and indicate their position. There is a metal group on the third carbon, so we add 3 metal before the parent's name. Finally, IUPAC name will be 3-methyl but 1-ene. That's how we name alkene using IUPAC system. Now, let's look at the basic preparation of alkene. There are 4 ways to produce alkene. The first method is dehydration of alcohol. This occurs through acid catalyzed dehydration using acid like sulfuric acid or phosphoric acid. The alcohol first gets protonated, then loses a water molecule to form carbocation, and finally undergoes deprotonation to form the alkene. Next, we have dehalogenation. In this process, hydrogen halides are eliminated from alkyl halide when treated with strong base, also resulting in alkene formation. Then, dehalogenation, where alkyl halide react with zinc, removing halogen atom to form alkene. Lastly is a cracking of alkynes, an industrial process that breaks large hydrocarbon into smaller, more valuable alkenes. It can be done through thermal cracking, catalytic cracking, or steam cracking. That's all for basic preparation method of alkene. Now, I will explain 2 key reactions of alkene: addition reaction and polymerization reaction. For the addition reaction, the double bond break and react with other atom. First, the alkane attack electrophile, forming a carbocation, then a nucleophile attached to complete the reaction. Next is a polymerization. In this process, many alkene molecules join together to form long chains called polymer. It happens in 3 steps: initiation, propagation, and termination. That's all for 2 key reactions of alkene. Lastly is a real-life use of alkene. We have 4 examples, which is plastic production, detergent and chemical, synthetic fabric, fuel and energy.
Hello and good evening. My name is NURFITRIANA with KHALID. Today, I will briefly explain about alkynes, one of the important group of hydrocarbon in organic chemistry. First, what are alkynes? Alkynes are hydrocarbons that contains at least one triple bond between carbon atoms. Because of this triple bond, alkynes are very reactive. The simplest alkyne is ethene, also known as acetylene. Alkynes follow the general formula, that is CnH2n-2. They are unsaturated hydrocarbons, which means they do not contain the maximum number of hydrogen atoms. Okay, so now let's look at how to name alkynes. The naming is actually so simple. We find the longest carbon chain that contains the triple bond. Then we replace the ending "-ine" with "-ine". For example, if there are 2 carbons, it becomes ethine. If there are 3 carbons, it becomes propyne. We also number the chain to show the position of the pre-. I will give 2 examples for the method of preparation for alkynes. One, from alkenes. Start with halogenated alkene, and next is from alcohols. So we should convert alcohol to alkyl halide first, then use strong base to make alkyne. Alkynes can easily react with other substances because they have a triple bond. When hydrogen is added, the triple bond becomes weaker and the alkyne slowly changes into an alkene and then into an alkane. For example, ethene can turn into ethene, and finally ethane. Alkynes can also react with halogens like bromine or chlorine. These halogens attach to the triple bond and form new compounds such as dibromoethene, and with more halogen, they become tetrabromoethane. Let's talk about one use of alkynes. So the very common example is ethene, which is used in oxyacetylene welding. This is because when ethene burns with oxygen, it produces a very hot flame that can melt metals. This makes alkynes useful in industrial work, especially for cutting and joining metal parts. So that is the end of my presentation for today. Thank you.
Hi, my name is GOPINATHAN, and today I'm here to explain about stereochemistry. Stereochemistry is the study of how an atom are arranged in 3D space and how arrangements are affecting the properties of the molecule. There are 2 types of isomers: constitutional isomers versus stereoisomers. Constitutional isomers are molecules that have same molecular formula but different connectivity of atoms. Example, butanol, and this is isobutanol, have same formula, that is C4H10O, but the atoms are connected differently. Stereoisomers have the same formula, molecular formula, same connectivity, but different 3D arrangement of atom in space. For an example, cis to butane, and this is trans to butane. For chirality, a molecule is chiral when cannot be superimposed on its mirror image, just like your left hand and right hand. And the most cause is a carbon atom, which is 4 group attached, is called chiral center. It's about enantiomers. Enantiomers are a pair of chiral molecules that are non-superimposable mirror image of each other, but they do have same physical properties except for 2 things. They rotate plane polarized light in opposite direction and interact differently with biosystems, especially enzymes. And the rotation of light is called optical activity. One enantiomer rotate light to the right, and others rotate light to the left. For an example, the real life examples are limonene, profane, and thalidomide. These examples shows how important chirality is in medicine, smells, and biological activity. Now it's about diastereomers. Diastereomers are stereoisomers that are not mirror image of each other's. They have different physical and chemical properties. For an example, cis isomers and trans isomers in alkenes are diastereomers. Next is about mesocompound. Mesocompound has chiral center, but it is overall achiral because it contains an internal plane of symmetry, so it does not rotate plane polarized light. Okay, finally, let's talk about racemic mixtures. Racemic mixtures contains equal amount of two enantiomers. Why? Because their optical rotations cancels out each other. So the mixture is optically inactive. So that's all for today, and thank you for listening to me. Bye.